Today I'm going to show you how to create an off-screen rendering pass. For this demonstration, we will be converting this iconic shader from ShaderToy, render it into an off-screen texture. To get started, we're going to create a new project that I'm going to place on my desktop. And I'm going to edit my first render layer and head over to select my main camera. Then inside the camera properties, I am going to enable frame buffer. As I enable frame buffer, I can see that now I have access to color attachment slots. I am going to create a new texture with the library selected. I'm going to go under Asset, New, Texture, and Attachment. I am going to create a 16-bit floating point texture attachment. Once created, I'm going to simply drag and drop it inside the first texture attachment slot here. To be able to render off screen, I'm going to need to have a material that is going to actually be connected to a shader that will actually do the drawing to my off-screen texture here. So once again, with the library selected, I'm going to go under Asset and create a new material, and Asset, New Shader, Fragment Shader. I'm going to go under Properties and Material and drag and drop this material here for editing, and I'm going to connect my newly created shader. It is now time to start coding this shader, so I'm going to go under the coding layout, select that shader. What we're doing here is basically rendering a full screen quad, which each vertex position are in the range of -1 to 1. And we're going to use an orthographic projection where the range is also -1 to 1 to ensure that we got a full screen quad drawing our off-screen texture. First thing that I'm going to do is edit my vertex shader, and I'm going to paste this code here that I'm having in my clipboard. What this code does is it's taking the vertex position, our -1 to 1, and convert it into a texture coordinate that is going to be in the range of 0 to 1, from the bottom screen to the top screen. I am going to head over to my fragment shader this time. I'm going to copy my texture coordinate and paste it here. I am going to remove my default main function, and I'm going to head over to ShaderToy and simply Control A, Control C, copy the whole code and paste it into as my fragment shader. I'm going to have a first compile run, and I can see that here they're using time, which is actually connected to the default macro here, which is using iTime, which is a basic built-in uniform from ShaderToy. And what we're going to do, we're going to replace for the equivalent in GFX, which will be a vector 4, and it will be a uniform vector 4, and it's going to be GFX stats. What GFX stats provides us is in the X component is providing us the delta time, Y is the application time, Z is the current frame, and W is the current frame per second. So in this particular case, we're going to need to use the Y component, which would give us the application time. The next thing that we're going to have to replace, I'm having here eye resolution, which is also a built-in uniform variable from ShaderToy that represent the width and the height of the screen. So we're going to declare the equivalent in GFX, which is going to be another uniform vector 4, and this time is going to be GFX viewport. The X and Y component provide us the location of the viewport on screen, and the Z the width, and the W the height. We're going to do a simple find and replace here, copying eye resolution and find text eye resolution dot X, which is our equivalent of GFX viewport Z, and eye resolution dot Y will be GFX viewport W, and we're going to replace that. Heading over to the main function, we're going to replace, because this is also like their own declaration, we're going to simply create a void main. And here we can see that they're actually calculating what we have been calculating in our, basically in our vertex shader earlier. We are going to replace that with texture coordinate 0. And here they are creating those band at the top and the bottom of the screen. We don't want that. We want to have like a full screen draw here. So I'm going to remove that code. over here, take out the bracket, and I can see that there's still residue of that code here, which I'm going to delete. And the last thing we're going to have to do is to replace the frag color, which is also one of their built-in uniform, for the good old GL frag color. I am going to compile that shader, and the next step will be to actually tell our renderer on our render layer, our first render layer, to actually use that material to draw with our camera that have a frame buffer object basically connected to it, attached to it. So what we're going to do is we're going to go under material and select our material here. Right away, I am not seeing anything so far, but if I have a preview of that texture, as you can see here from the library preview, my scene is actually drawn offline, off screen, and my texture is now updated. If I update the application time, which is 0 at the moment, if I push here, I will start increasing the application time. And as you can see, my texture is now updated in the background while my viewport is still basically black. If I enter edit mode now for that render layer, having the viewport selected, I can see that my texture is actually drawn in the background as I'm editing that layer. But as a final application display, pushing spacebar, it is basically black. The workflow that I show you can be applied for any type of post-processing, off-screen processing that you might want to implement inside your own rendering pipeline.